This is 1.2 exponentials and radicals and 1.3 algebraic expressions. We start with a base of a, exponent of m, and you multiply by another base of a and an exponent of n. Remember, you add your exponents and you're going to get a base of a with exponent of m plus n. When you divide a base of a, exponent of m, by a base of a with an exponent of n, you're going to subtract and get a base of a of m minus n. Base of a raised to the m power, and I'm going to raise that again to the n. You're going to multiply that, so that would be a to the m n. Let's change it up. What if I have an a and a k inside now, and I raise that to the n power? Then both of these would be multiplied, so I have an a raised to the n and then also the k raised to the n. Now let's divide those. If I have a over k and I raise that to the n power, then both of those would also be raised to that. So that would be a raised to the n power over k raised to the n power. And I can't do anything to those because those are different bases. How about if I have a to the n and k to the n, and let's raise those to a different variable. Let's raise those to the x. So those would be multiplied basically. So that would be a to the nx and k to the nx. Okay, so what if I have a to the 0? Anything to the 0 power is going to be 1. In fact, if I wrote anything and raise that to the 0 power, that would be 1. If I have a raised to the negative n power, that can be rewritten as 1 over a to the n power, and that becomes a positive now. Or if I have 1 over a to the negative n, I can make that positive by moving it to the top of the fraction and making that a to the n. A over k, and let's raise that to the negative n. If I want to make this positive, I can move it to the bottom by doing 1 over a over k, and that's pretty nasty. Or I can just simply flip it and say k over a. And that's the same thing as saying leave, change, flip, and now that would be positive. So it'd be k over a raised to the nth power. All right, when you're working with radicals, let's say I have a raised to the 1 over n. That is the same thing as saying, say, the nth root of a to the first power. So your 1 is on top and your n is going to be on the bottom. So if I have a to the m over n, that's the same thing as saying the nth root, a raised to the m power. Another way you could write this is I could say the nth root of a, and I could move that m out here. And sometimes moving the m on the outside is a whole lot easier if you're squaring it or cubing it. What if I take the nth root of a and I want to multiply it times the nth root of k? Well, since these are the same root, I can rewrite that as the nth root of a times k. And same thing if you've got a division problem. If I've got the nth root of a divided by k, I can rewrite that as the nth root of a divided by the nth root of k. So it says to simplify, and it also is going to no negative exponents in your final answer. Problem, I'm going to say the quantity of 3x squared and y to the 5th times the quantity of a negative 2 times x and y to the negative 8. Now, if this was my final answer, this negative 8 is the only one that I'm really worried about being as a negative value. The negative 2 is just a coefficient, and that doesn't matter. So the first thing I would do is multiply my my coefficients. So 3 times negative 2 would give me a negative 6. Take my x values and multiply them. So that would give me x is the exponent of 1, so that would be x to the 3rd. Take my y values, go ahead and multiply those. So that means you're adding your exponents. So 5 and a negative 8 gives me a negative 3. But it says no negative exponents. This is the only thing that's negative here. I know this is a negative coefficient, but that doesn't matter. So if I want to make this positive, since this is on top, the only thing I need to do is move it to the bottom of the fraction. So my final answer would be negative 6x cubed over y cubed. And just moving it to the bottom makes it positive. And that'd be my final answer. I'm going to do the quantity of 3x to the negative 2, y to the 4th. I'm going to raise all of that to the 3rd power. The first thing I would do is get rid of this exponent here and go ahead and basically distribute it inside. So 3 to the 3rd power, that's 27. X to the negative 2 to the 3rd power, that's a negative 6. And y to the 4th to the negative 3rd, or to the 3rd power, distribute that in, and that's going to give me a 12. And again, since I need no negative answers or exponents, this is the only one that's negative. Move that to the bottom of the fraction and you should have your final answer. So 27, y to the 12th, and put that over x to the 6th, and you have your final answer. So when you have the square root of 18, I want to add that to the square root of 50. So back in Algebra 2, geometry, and so forth, the only way I can add these two is to have a common square root. So I need to break these down. I need to do a factor tree. So I can break this down into the square root of 9 and the square root of 2. This factors out to be 3, square root of 2. I can factor the square root of 50 to the square root of 25 and the square root of 2. Anytime you can find a perfect square root, that makes it a whole lot easier. And that's going to give me 5 square roots of 2. So now that I have both of them being the square roots of 2, I can add them together to get 8 square roots of 2. And that should be my final answer. 2x to the 3rd power times the value of 5xy. Let's put that over 20xy squared. So how about we simplify the top first, multiply my coefficients, which gives me a 10, multiply my x values, that's going to give me x to the 4th, and a y, over, my bottom stays the same. 10 over 20 is just a simple fraction there, so that's going to simplify to a half, so that's 1 over 2. And you don't have to put the 1. Remember, when you're dividing x to the 4th over x to the 1st, you're subtracting. So that's going to give you x 4 minus 1, which is x to the 3rd. And this is a 1 minus 2, so that's going to give you y to the negative 1. With no negative exponents, that's going to give me x to the 3rd. My 2 stays down here, and my y needs to move to the bottom to give me a positive exponent. How about if I just have an 8 raised to the 5/3? Now, I just want to simplify to the smallest possible number. With no calculator, what I would probably do here is change this to a square root. So remember, this number goes inside and this goes out. So this is going to be the cube root of 8 to the 5th power. Now, since I don't have a calculator, I'm never going to go ahead and multiply this out. Anytime you want the cube root of something, this is how I rewrite this. This means the cube root, and I have 5 of these 8s. If I have 3 of these right here, the cube root of 8 to the 3rd power is going to cross this out, and I'm going to take an 8 outside. Now, if you can take the cube root of 8, the cube root of 8 is a 2. That means that goes outside. There's another 8, so the cube root of 8 is 2. My cube root is gone. I no longer have it. So all I need to do is multiply 8 times 2 times 2, and my final answer is 32. How about negative 27 raised to the negative 2/3? Well, the first thing I would do is this negative 27 really means nothing. You don't have to worry about that, but the negative exponent does. So to get rid of the negative exponent, remember, you move it to the bottom. So this is still a negative because I've got the negative 27. So this is a negative fraction, and I've got 27 to the 2/3 now. So I need to worry about this 27 here. So I've got a negative 27, or a negative fraction really. So how about we do the cube root of 27, and we're going to square it. In fact, I'm going to rewrite this with the squared on the outside to make it a little bit easier. And really this negative here, let me do this here. And move this negative out here so it makes a little bit more sense. It's because it's a negative fraction. And let's find the cube root of 27, which is 3. And now let's square it. So now we have a negative 1/9. How about let's start off easy. How about x squared plus 2x minus 15? This is just a basic one. Remember, what multiplies to give you negative 15 and adds to give you 2. So the numbers that multiply to give you negative 15 would be a negative 5 and a positive 3. That should be x plus 5 and an x minus 3. Y'all should be able to do that shortcut by now. When you are working with a difference of squares, remember it's a difference of squares. Remember factor, just like before. You have an A and an A. They factor to a plus 4 and a minus 4. And again, these should be quick things that you should be able to multiply or factor really quick. 15 a cubed m squared minus 25 a to the 5th power m to the 4th plus 35 a squared m to the 4th. Now if you look at this, you should see basically a trinomial, and you should notice that you can't factor it like you did number 7, but you should be able to take some common factors out. Where I can see I can take a 5, I can take out a squared, and I can take out an m squared. So if you factor out, that means you're dividing. That leaves me with a 3. That leaves me with 1a and no more m's in this first term. If I take out all of this in the second term, I'm left with a 5, an a cubed, and an m squared. In the last term, I'm left with a 7 and an m squared. And there is absolutely nothing I can do from there. How about a 3x raised to the 3 halves minus 9x raised to the 1 half plus 6x raised to the negative 1 half. Okay, now on this one, again, I see 3 numbers. I definitely see a 3 I can take out. I see an x. Now on your exponents, you're going to take out the greatest common factor, or, well, I should say the least common multiple here. So out of these, you're definitely going to take out a negative, so I'm going to take out that. The number, just like up here, I had 2 a's in common with all of these. Okay, and I had 2 m's in common. So it looks like I have a negative 1 half that I can take out. And I know there's no negative here, but if you have a negative in any of them, make sure you take it out. Now, when you've got this, in this problem before, remember you're always, when you take out the number, you are subtracting. So in this right here, when I take out a 3, there's no more 3. When I take out an x to the negative 1 half, I am subtracting out this negative 1 half. So negative 1 half minus the 3 halves leaves me an x squared. Oh, that was totally wrong. That is not x squared. That would be x to the 4 halves. Minus, take this out. This is going to be a 3x. If I take a negative 1 half out of a 1 half, I am left with 2 halves. Remember, I'm subtracting. If I take a 3 out of this, I'm left with a positive 2. And I have no x. From here, it looks like I have exponents that I can go ahead and add. So you're going to go ahead and simplify. So my exponent out here stays negative 1 half. Inside, 4 halves, and I can go ahead and add these. This is going to be, let's see, this is x squared minus 3x plus 2. I'm not adding those, I'm just simplifying. That was silly. Okay, from here, can we do anything with this? Does this factor? Meaning, can I multiply something by 2 and add to give me negative 3? So what times what gives me negative 2 and adds to give me negative 3? Isn't that negative 2 and negative 1? So that would be x minus 2 and x minus 1. This would stay. Now the only thing we need to worry about is, do we have any negative exponents that we need to change in order to be a positive? And this is the only thing that I see. So let's rewrite as our final answer and we're done. So 3 x minus 2 and x minus 1 over the x to the 1 half. How about x plus 4? And let's raise that, let's square that. And let's do 2 times another x plus 4. And let's do minus 3. Hopefully you noticed that I wrote x plus 4 twice. So let's do a u substitution. Squared plus a 2u minus 3. So basically I said u is equal to the x plus 4. To make it a little bit easier, once you replace this, you should see a trinomial here, which is really easy. What times what gives you -3 and adds to give you 2. So this is going to factor to u minus 1 and u plus 3. Now that you have factored that, you can replace back in what you just took out, the x plus 4. So this is going to be x plus 4 minus 1 and x plus 4 plus 3. And I would go ahead and simplify that. So that would be x plus 3 and x plus 7. This is 3 with a parenthesis of 2x minus 1, and that is kind of squared. I'm going to multiply that times 2. I have a parenthesis of x plus 3. I'm going to raise that to 1/2. I'm going to add all of that to a parenthesis of 2x minus 1. And I'm going to cube that. I have a parenthesis of 1/2. And then I have an x plus 3 raised to the -1/2. It looks like we only have 2 numbers here. So you should find something common between both parentheses. I'm going to try to simplify some of this. On the left side, I have 2 whole numbers here. That's 6. I'm not going to go ahead and multiply this out. I just see a 2x minus 1, and I have another parenthesis of x plus 3. But I did notice that I have these things in both parentheses. I have a 1/2 here. I'm going to move that to the front, so that's a coefficient. I have a 2x minus 1, which I see over here in the first one. And I have an x plus 3, which is nice. Have that one in the first one as well. In the coefficients, what can I take out of both of those? I have a 6 here and a 1/2 here. So the smallest I can take out is 1/2. In the parentheses, I have a 2x minus 1 and a 2x minus 1. So I can take out 2 of those. Now I'm factoring out. That's what I'm doing. I have an x plus 3 and an x plus 3. And it looks like I can take out -1/2 of them. Okay, so I'm factoring out. So if I take out a half, remember you're dividing. So 6 divided by a half would be 12. If I take out a 2x minus 1 squared, I no longer have one. If I take out a -x plus 3, then it looks like I'm going to have an x plus 3. Okay, now I'm going to take all of this mess out of my second part of the problem. And it looks like I'm going to have a 2x minus 1. And that's it. Okay, in this side right here, it looks like I can simplify. So let's look at, bring down the left side and do nothing to it. And simplify the inside. So this is going to be 12x plus 36 plus 2x minus 1. In fact, I'm just going to keep going here. This is going to be 14x plus 35 to x plus 5. So that just factors. Okay, so what I have is all of this and this, but I have a negative exponent. So that's what I'm really worried about. Since I have this, I've got a 7, 2x plus 5. I'm going to start with that. I have a 2x minus 1 squared. Okay, this is moving to the bottom, and I haven't forgot about my 1/2. I'm thinking this is 1 over 2. I've got my x plus 3, and this is 1. Very last problem. X raised to the 1/2 minus 7x to the 1/4 plus 10. And I'm going to say let u equal x to the 1/4. If x to the 1/4 here, this would be x. Nope, I'm going to say u. I'm going to say this is u squared. This is going to be 7u. And this is going to be plus 10. If you do a u substitution, it makes it really easy to see that this is going to be u minus 5. And this is going to be u minus 2. Then go ahead and replace your x's back in. Your final answer would be x to the 1/4 minus 5 and x to the 1/4 minus 2. And that should be your final answer.